Okay, so in this video I'm going to go over the review sheet for this unit in graph theory. I'm just going to go through each problem and explain the process of thinking for it, how to do each problem, and you can use this video as a resource as you go through the answer key or through the review sheet. Okay, just to help you prepare for the test. Okay. So starting with number 1, looking, well, 1 through 6, we're looking at the same graph. Okay. It says vertex E is adjacent to, okay, if I'm looking at E, remember the vertices that it's adjacent to is just the ones that the edges are connecting it to directly. So in this case, it would be adjacent to D and adjacent to B only, and then that would be answer choice C. Okay. The degree of vertex D, number 2, okay, remember, degree is just the number of edges coming out of it. So for D, we got 1, 2, 3, and 4. Okay, so that would make answer choice B. All right. Let's look at the degree of C for number 3. So the number of edges coming out of it is 1, 2, 3, 4. Remember, loops count twice. So you got 4 lines coming out of C. It has a degree of 4, which is B. Number 4 says, which of the following is not a path from vertex D to vertex A? All right, so this was like on your quiz. People kind of got this one wrong. So you're going to have to check all these. Okay, so for the first one, for A, DEB, DCBA. Okay, well, I'm going to start at D, going to E, to B, to D, to C, to B, and back to A. Well, if you notice that worked out, so that is a path from D to A. So I can cross off A. Well, let's try B. B says D, C, C, B, A. So starting at D, going to C, back around C, to B, and to A. Well, again, that was a path that worked, so I can cross that one off. All right, let's try C. That says D, C, B, A. I'm going D, C, B, A. Again, that works. So C's out. Lastly, DA. D to A. Again, that one works. All of the following are paths from D to A, so that means their answer choice is E. All of the above are paths. Okay. Number 5 says, which of the following is not a circuit in the graph? Okay, so looking at all of these, well, again, we're going to have to go through, kind of like we just did with number 4, and identify which ones are not circuits. Okay, so starting with A, it's B, C, D, B. B, C, D, B. It works. So A's off. With answer choice B, it says B, D, E, B, A, D, B. So you're going to have to trace and see if that works. B, D, E, B, A, D, and then over to B. Okay, well, there's no way to get back to B, so that's not a circuit. That's impossible. The only way to do that is to backtrack, and we can't do that. Okay. So it has to be B. Again, you can check the other answer choices, but that is the only circuit that does not work in this case. The other ones do. Okay. Number 6 says, which of the following is a bridge of the graph? Okay, well, AD for A. If I cross off AD, is it disconnected? No. Remember, that's all a bridge is. It's just edges that if I were to take them out, would cause the graph to become from connected to disconnected. DE, cross that out, it's still connected. If I cross off BD, the graph is still connected. It's not broken into pieces. And if I cross off AB, the graph is all still united as one graph. So there is no bridges in this graph. Okay? I'm going to ask questions just like these 6 on the test, just like you saw on the quiz. Okay, a few people missed this on the quiz. Number 7 and 8 are asking about which of the following graphs above have an Euler circuit and an Euler path and all that good stuff. Okay, remember, that's all based off of the degree of each vertex. Let's go through each graph and find the degree of each vertex. So this is 1, 2, 3, 4. 2, 4, 3, and 3. So exactly 2 odds means that we have a path. Okay? This next one, this is 3, 4, 1, 2, 3, 4, 5, 4, 3, 4, and 3. Okay, so if we have more than 2 odds, so here we got 4 of them, then that means there is neither an Euler circuit or an Euler path. And then lastly, we got 2, 4, 2, 4, 2, 4, and 2. They're all even. That is a special graph. That means that we have an Euler circuit, and that's how we identify. Okay, so let's read through this. Which of the graphs has an Euler circuit? Well, that's only graph 3, so that's B. Which of the graphs has an Euler path, but no Euler circuit? That's only graph 1, so that's A. Okay, again, you'll see this on the text. A graph with 11 vertices has an Euler path, but no Euler circuit. The graph must have, okay, so again, 11 vertices has an Euler path. Okay, if you see that, you should be thinking exactly 2 odds. Okay, that's the only way that could work. So A says 2 vertices of odd degree and 9 vertices of even degree. Well, that is literally what I just said. Okay, it has exactly 2 odd degrees and the rest are even, so it has to be A. It can't be B because that would be an Euler circuit. It can't be C because, well, that's impossible. And it can't be D because 2 vertices of even degree doesn't make any sense. We've never talked about that. So it's A. So it's just understanding the definition of an Euler path. Okay, this question right here, for those that are watching this video, here's your hint. People miss this question all the time on the test because they always forget about the north bank and the south bank. Okay, let's see what I mean. In a certain city, there is a river running through the middle of the city. There are 4 islands and 9 bridges as shown. A graph model might have what? A lot of people would just say 4 vertices and 9 bridges. Okay, a lot of people want to say answer choice A, but don't forget about the north bank and the south bank and the 4 islands. Okay, boom, 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 boom. There you go. There's your graph model. Okay, it has 6 vertices and 9 edges. Okay, 9 bridges, 9 edges, but 6 vertices because of the north and south bank. Okay, so your answer choice is D there. Okay, the number of edges in a K10 graph is what? Well, that's telling you a completed graph with n vertices, 10 vertices. Okay, remember that means you have 10 dots all connected to all the other dots. We have a formula for the number of edges. Okay, remember these formulas from the quiz. N times n minus 1 over 2, where n is equal to 10 in this case. Okay, so your answer is 10 times 10 minus 1 over 2, which ends up becoming 45. So your answer choice is D. Know that formula. Know the formula for the upcoming question number 12, Hamiltonian circuits, and you should be good. In a complete graph with 14 vertices A through N, the total number of Hamiltonian circuits, including mirror images, that starts at vertex A is what? Again, we have a formula for this. All right, number of Hamiltonian circuits is N minus 1 factorial. Remember this, okay? It goes with Hamilton circuits. So our N value in this case is 14. So my answer choice is 14 minus 1 factorial, which our calculator will give us way too big of a number. So simply it's just 13 factorial, which is B. Okay, again, you saw this question, these next few questions on your quiz. You'll see it on your test. Okay, so make sure you're good with these. What is the weight of edge BC? Well, BC is right here. That has a weight of 7. The number associated with the line. And when we talk about nearest neighbor and brute force, that's usually talking about price. So it says find the nearest neighbor tour starting with vertex A and give the weight of the tour. Okay, so remember with nearest neighbor, it all depends on where we start. We're starting at A. Nearest neighbor says to go to the next cheapest point. Okay, so it's either going to go to D with 6, C with 4, or B with 11. The cheapest one it can go to is C with 4. Okay. Then from C it has two options. It can go to D or B. Whichever one's cheapest from there is the next one it goes to. Turns out to be D with 5. Alright, trying to go to every single city. There's only one left, so we're going to B with 3. And then finally we got to go back home in order for it to be a Hamilton circuit. So we're going back to A with 11. Okay, so there's my answer, A, C, D, B, A. It started with the A, ended with A, and the total value is 23. Okay, that's what I'm looking for. There's your work for nearest neighbor, no big deal. Our work, and what I'm looking for brute force, is that you list every single Hamiltonian circuit and pick the least one. A lot of people in the quiz did not list every single Hamiltonian circuit. I would like to see all of it. Okay? So let's go through the process for number 15, Hamiltonian, or brute force method. Okay? So remember, step 1 is identifying how many Hamilton circuits you need to check using our formula, n minus 1 factorial, okay, which in this case, n minus 1 factorial, which is 4 minus 1 factorial, because we have 4 vertices, which equals 6. But remember that includes mirror images, so we're only checking 3. And honestly, guys, we've done this exact example so many times, it's not even funny. Okay, so let's list all 3 of our Hamiltonian circuits that go with it. The first one is A, B, C, D, A. The next one is A, C, B, D, A. And the last one is A, B, D, C, A. Those are 3 distinct ones. They're not mirror images of each other. All right, there's ones going around the box. Okay, there's ones going in this direction right here. And then the last one is going in this direction right here. Okay, so we've found those Hamiltonian circuits so many times, but just be prepared on how to find those. Okay, so we got to figure out which one's the cheapest to figure out our answer. So we give their weights. Here it's edge AB, which is 11, plus BC is 7, plus CD is 5, plus DA is 6, for a total of 29. ACBDA, well, that's just going to be 4 plus 7 plus 3 plus 6, which is 20. And then for the last one, ABDCA, it's going to be 11 plus 3 plus 5 plus 4, which is 23. So the one that gave me the smallest one was ACBDA. Okay, so with a weight of 20. And you could have given me the mirror image as well. That's completely fine too. Okay, you could have given me ADBCA as well. Either one's fine. All right, you'll also be expected to be able to do nearest neighbor method using a chart. Okay, so sometimes this helps organize it, especially when we have a bunch of vertices. So, let's just go ahead and go through it. It's kind of blurry on your paper, but this is A, B, C, D, E, F. Same thing here. A, B, C, D, E, F. Okay, so let's say we're starting at A. Okay, so we're starting at vertex A, which means we're looking at this first column right here. Okay, so you're trying to find the next cheapest place to go to. Okay, the cheapest number in this column, which is 13. Okay, which corresponds to B. So the cheapest place to go from A is to B with a weight of 13. Okay, so I go over to B's column now, because that's the city I'm in. The next cheapest one to go to is F with 11. Okay, so I'm going to, and that was after crossing out A. So I'm going to F with 11. So when I go to F's column, I can ignore A and B because I've already been there. So while I'm in F, the next cheapest place to go to is going to be C with 12. Okay. So when I go to C's column, I've been to A, B, and F. So from C, I'm either going to D or E. The cheapest one is E with 17. So E is 17. So when I go to E's column, I've been to A, B, I've been to F, I've been to C. I only have one city left to go to, and that's D, okay, with 19, a weight of 19. And when I get back to D, I've been everywhere, so I'll have to go to my returning spot of A with 27. And the chart you're going to get on the test is going to be about that size. Okay, so just be prepared on how to do that. And that total weight, I believe, is 99. Okay. Okay, so remember, I'm going to ask this kind of question again on the test. And being able to distinguish between nearest neighbor and brute force. Okay, so nearest neighbor method. Nearest neighbor. It's not optimal because it doesn't always give you the cheapest circuit, but it is approximate. Okay, it is time efficient as well. Okay, it's approximate because, well, it's approximately giving you the best one. But the good thing about it is it's efficient. Okay, so nearest neighbor is approximate and efficient. Remember that brute force is the opposite. It's optimal, but inefficient. Okay, so keep those distinguished. Memorize those. All right, 18 and 19, going back to the Hamiltonian circuits. Okay, going back to the edges, going back to complete graphs. This is working backwards. I'm telling you how many circuits we have now. I'm telling you how many edges that we have now. We got to work backwards with our formulas and find n, the number of vertices. So we have 720 Hamiltonian circuits. And that's going to equal n minus 1 factorial. Okay? N minus 1 factorial. We don't plug 720 in for n. We're looking for the n value that gives us 720. Now, remember, the only way to do this is to guess and check. And we only have so many numbers to pick from. But it turns out in this case that n equals 7. All right, if I plug that in, that would be 7 minus 1 factorial, which is 6 factorial, which equals 720. Again, if you need to know how to do factorial in the calculator, it's math over to PRB, and it's number 4. That'll give you your explanation point. Okay, number 19. This is the one you gotta remember how to do a little bit of math with. Okay, Kn has 528 edges. How many vertices does it have? So we use the formula for edges, which is n times n minus 1 over 2 equals 528. Okay, remember we had a process for this. We're trying to get n by itself, so we multiply both sides by 2. And we get n times n minus 1 equals 1056. Okay, from here is where we use the argument about geometric mean. We got a number times a number 1 less than that. Okay, so remember that if I take the square root of that product, the two numbers, the answer I get is a decimal in between them. So from this point, you take the square root of 1056, which is 32.496. Okay, so that means that the two numbers that are multiplied together are 32 and 33. If I multiply those two together, it gives me 1056. But I want the bigger of the two numbers. I don't want n minus 1, I want n. So my answer is 33. Okay, and you can always check your work by plugging it back in. 33 times 33 minus 1 divided by 2 is 528. Okay, so memorize that formula, memorize that process. Okay, with number 20, now we're getting into the stuff after the quiz, the new stuff with directed graphs or digraphs. So I will ask questions just like this on the test with a given diagram. Use the diagram below to answer the following questions. Give the vertex. That should be a 100 from everybody. Just list all the vertices. Okay, so that's A through F. A, B, C, D, E, F. All right. Now, the next one, people always tend to forget some of them. They always forget some of the arcs in the arc set. Remember my suggestion. Okay, start off in alphabetical order. Start off with A. Okay, A's got two arcs coming out. A, D, A, B. Because remember, order matters. I don't want to put A, F, or A, E because that's the opposite. So A, B, A, D. Okay. Moving on to letter B, it's got two lines coming out of it. B, D, B, C. Moving on to C, it's only got one line coming out of it. Okay, so I'm only going to say one of those arcs, which is C, E. Okay, moving on to D, it's got two lines coming out of it. D, E, D, C. Moving on to letter E, it's got three coming out of it. E, A, E, B, E, F. And then lastly, with letter F, we got three coming out of it. F, E, F, A, and F, D. And there you go. Got them all accounted for. I went in alphabetical order. I made sure I had them all for set. Very nice. Okay, let's do the in degree and out degree for each of the vertices. Okay, let's do it for, let's see here. A, B, C, D, E, F. All right, remember that the in degree is all of the ones that have arrows pointing at it. So with A, we got 1, 2. With B, we got 2. With C, we got 1, 2. With D, we got 1, 2, 3. With E, we got 1, 2, 3. And with F, we got 1. Okay? So it's just the arrows that are pointing into the vertices. So now let me do out degree. Out degree is all the ones that are pointing out from the vertices, have arrows coming out of them. So for A, it's 1, 2. For B, it's 1, 2. For C, it's 1. For D, it's 1, 2. For E, it is 1, 2, 3. And then for F, it is 1, 2, 3. Okay, makes sense. Good to go. Awesome. All right, don't let these next ones confuse you because they're not too bad. It's just kind of have to memorize what these mean. So a vertex A is incident to A. So you find a vertex that is incident to A. Okay. Now, whenever I say that, I'm meaning find a vertex that's pointing to A. What vertices are pointing to A? How about F and how about E? F or E. Okay. What about find a vertex incident from D? By that I mean find a vertex that's coming from D. So a vertex that D is pointing to. How about C? How about E? And then lastly, find an arc adjacent to FD. Remember, if I want to find an arc that's adjacent to another arc, it has to start where the other one ended. This ended at D. The other ones have to start at D for it to be adjacent. So again, how about DC, or DE. And there you go. There's the digraph basics you should be able to answer. Okay, we're omitting 21. We don't do those kind of problems, so you can omit that. We're going to take it off. All right, but let's look at 22. 22 is pretty much identical to the type of question that you're going to have on a test. I do not want you to get this one wrong. Okay, so really pay attention and make sure we know how to do this problem. Okay, so it says draw the project diagram. So we're going to have a start and we're going to have an end. And it says there are 6 computer programs to complete listed in order of time to complete A, B, C, D, E, F. Both 4-minute programs must be completed before starting 7-minute task, and the 9-minute program must be completed before the 5-minute. I know that sounds confusing, but I think it might be helpful to create a little T-chart to organize our information with our tasks and our prereqs. Okay, so let's do our tasks. Our tasks are A through, well, F. A, B, C, D, E, and F with their processing times of 9, 7, 5, 4, and 4. I think on the test I give you a problem like this where I just give you their processing times, so it might be helpful to label them A through whatever. Okay. Now let's list their prereqs. Okay. The first one says both 4-minute programs must be completed before starting both 7-minute tasks. So in order to start B, E and F have to be completed because they're the 2 4-minute tasks. And same with C. Okay. And then it says, and the 9-minute task, or I'm sorry, the 9-minute program must be completed before the 5-minute program. So that means that A has to be completed before D. Okay. So we got our prereqs, we got our task. Let's do our project diagram. Okay, so remember, whenever I draw this, I always start. Whenever I draw this, I always start at the left. Okay, and then I have start pointing to everything that's ready, which in this case is A, E, and F. So it's going to be pointing to A, E, F. A with a processing time of 9, B with a processing time of, oh, not B, I'm sorry, E with a processing time of 4, and F with a processing time of 4. Okay. From here, let's have the prereqs being pointed to the ones they have to go to next. So like A has to point to D, right? A has to be completed before D with a processing time of 5. Now B and C, okay, E and F both have to be completed before B and C are completed. So how about B with its processing time of 7 and C with its processing time of 7. So like both E and F have to be completed before B starts. E and F both have to be completed before C starts. And then finally, once all 3 of those are completed, okay, we're done. And there's your project diagram. Okay, these last few problems are pretty much how it's going to be on the test, okay, with scheduling, with priority lists, with projects, diagraphs, the critical times, all that stuff. It's going to be kind of split up the same way here. So let's first do an example where I'm giving you the priority list, okay? So it says find the finishing time and schedule for the given project diagram and priority list. We're not talking about critical time or critical path yet because I'm giving you the project or the priority list. So my priority, I want to start off with A. Is A ready? Yes, it's ready. It's pointing from the start. So I'm going to go ahead and put A in my processor 1 with 7. Okay, so I've done A, now moving on to B. Well, B's ready too. It has no prereq, so as far left as I can go is P2 with its processing time of 3, so I'm going to cross B out. Moving on to C. C is ready as well, so I'm going to take it as far left as I can go, which is again at P2. So that's 1, 2, 3, 4, 5, 6, 7, and 8. So C's done. Okay, now moving on to D. In order for D to be completed, B and A have to be complete. So this just got to be as far left as I can go without overlapping with A and B. So still, that will work out in P1 with this processing time of 4. Okay. So moving on to E. Well, E's prereq is only one thing. It's B. It's got to be past B. And really, it does not matter where I put it because it's the same spot for P1 or P2. So let's just give it to P1 with 6. There's 6 E's. Now, moving on with F. Okay, F has 2 prerequisites, E and C, so it's just got to be past both E and C. Okay, so it's got to be somewhere at this point. And since we have 2 left, well, it really doesn't matter. It's got to be past either point at E or P1 or P2. So let's just give it to P1, just in case. So I'll give 2 F's right here. Again, it does not matter which one I gave it to. And then lastly for G, it just is prereq as D. So I can either put it here or down here, but if I put it down at P2, it's past D, so we're good. So let's just put it as far left as we can, right here. 1, 2, 3. This would go all idle, and we finish at 19 hours. So with that priority list, we finish in 19 hours. Might not be the minimum amount, but based off that priority list, it is. Okay, so that's one question I'll ask for you. Okay, let's try another example, okay, where I give you the priority list. Okay, so exactly what we did before, but now I'm giving you 3 processors. Okay, so starting at the list. H is my first. Can I do H? No, it's not ready. G is not ready. Okay? F is not ready. E is not ready. None of these are ready. D is not ready. The only thing that's ready is C and B. So the first one I approach is C. Okay? Give that to P1 with 4. 1, 2, 3, 4. Moving back on the list. H isn't ready, or G, or F, or D, or E. None of those are ready. The only thing that's still ready is B. Okay, so it has no prereq. Let's give it to P2 with a processing time of 5. Okay, so again, start from the beginning. Is H ready? No. Is G ready? No. Is F ready? No. Is E ready? No. Is D ready? Well, yes. Okay, because both B and C are complete. It just has to be past this point right here, past B and C. I don't care who I give it to. I think it might be best to maybe stick with P2 so there's no idle gap. So maybe like right here, D1, 2, 3, 4, 5, and 6. Either way, it's going to go that far. So D's out. Going back on the list. Can I do H? No. Can I do G? Well, what's G's prereq? G's prereq is both D and E. I've completed D, but I haven't completed E, so I can't move on to G just yet. Can I do F? No. Can I do E? Well, E's prereq is D. And only D. So yeah, I can go to E next. As long as it's past this point right here. Past 11. So again, I can put it wherever I want with P2, P1, P3, but I'm going to try to decrease idle time. So I'm just going to give it to P2. I don't want there to really be much gap. So 1, 2, 3. Alright. Can I do H? No. No. Okay, because both A and E have to be completed, and they're both not. Can I do G? Well, in order to do G, both D and E have to be completed, and they both are. Okay? So again, I'm going to give it to somebody past this point right here. I don't know, it's really starting to not matter. Let's bring P3 involved, maybe give him G. So now G's out. Okay. So can I do H? Well, E and A have to be completed. A is not completed, so I can't do H. Can I do F? Well, the only thing that needs to be completed for F is E, and that is completed. So it's just got to be past the point E. I'll give it to either P1 or P2. I don't know, I'll just give it P2. As long as it's past the point of E. Now F's out. Okay. And again, these things can all be kind of switched around. Like G and F could have been vice versa. It could have been switched. It doesn't matter as long as there's no overlap. Okay, no overlap with prereqs. Okay. So now, can I do H? Well, E and A have to be completed. I haven't done A yet. Let's do A. Well, if I go to A, okay, A's only prereq is C. So let's put A somewhere, okay, where it doesn't overlap with C. Which, honestly, I can either put with P1 or P3 down past the point of 4. Let's just give it a P3. How about 5 A's right here? Okay. He was idle up until he started working on that. Then he was idle when he got to G. All right, as long as A's past its prereq C, that's good. And I can be able to fit it kind of previously a little bit there. And now I can probably do H. It's got to be past E. It's got to be past A. So the point where it's past E and A is right here at 14, and I can squeeze that in with P1. So I've got 2 H's right here. Okay. Sweet. And this whole time right here he was idle. So it looks like that we finish again in 19 hours. Okay. So that was kind of hard. That was kind of hard as far as it goes, but you won't get one quite that confusing on the test. The test will be much like the one kind of down below it here, number 2, with 24. Finding the critical path, finding your own priority list, that kind of stuff. So let's go ahead and go through that one together. Okay, so first step in using the critical path algorithm is to identify the critical times of all the vertices. Okay, I kind of used to give you a little blank there to fill them all in, but let's just kind of do it together. Remember, backflow algorithm says that I'm going to start with the ones pointing it in, and their critical time is just their processing time. Okay, so like if I go to E, it's pointing to 3 things. The backflow algorithm says, all right, which one is the biggest one that it's pointing to? In this case, E is pointing to F. All right, so that'll be 3 and 5, which make 8. Okay. Now if I move on to D, D's pointing to 2 things. Which one's the biggest, the 8 or the 4? Well, it's the 8. So 6 and 8 make 14. A's only pointing to 1 thing, so that's 5 and 2, which makes 7. C's pointing to 2 things, so that 4 is going to be added to the bigger of the 2, which is 14. So that'll make that 18. And then lastly, B is pointing to only 1 thing, so that's 5 and 14, which is 19. All right, so the biggest number that the start is looking at is 19. So that means that our project minimum time is 19 units of time. Okay, that means by the all said and done, it's going to stop right there at 19. Okay, right there at 19. And if it doesn't, if it goes short of that or past that, you've done something wrong. Okay, so what was the critical path? What was the path that gave us that 19? Well, it was start to B, to D, to E, to F, and to N. So again, that was start, B, D, E, F, and N. So we use those critical times and list our priority list in the order of those critical times. Okay, highest to lowest. The highest being B with 19, all the way down to the lowest H with 2. So that would be B, C, D, E, A, F, G, H. Okay. So let's go through the process again. Okay, starting off with scheduling. P1, B, it is ready with processing time of 5. So I'm going to put 5 B's in P1. Okay, B's done. Moving on to C. C is ready. Okay, ready from the start. So why not just go ahead and give that to P2 as far left as I can go. 1, 2, 3, 4 C's. Let's move on to D. Okay, D only has one prereq, and that is B. Okay, so as long as it's past B, we're good to go, which is past hour 5. So why don't I just stick with P1? Keep a closed gap there. So with a processing time of 6. So D's out. Moving on to E. All right, well, E only had one prereq, and that was D, and D is complete. So again, I want to keep it as far left as I can go without overlapping with D. So again, I don't know, just so we don't have the overlap, why not just keep it with P1? That's fine with me. 1, 2, 3. Okay, so now E's out. All right, moving on to A. A only had one prereq, and that's C. So as long as I keep it past C, we're good to go. So past hour 4. And again, I can give it to P2 or P3. All right, I'm starting to feel bad for P3. Why not just go ahead and give it to him? 1, 2, 3, 4, 5. Okay, so A's out. That means that P3 was idle all the way up until hour 4. Okay. So moving on to F. F only has one prereq, and that's E. So it's got to be past E. So again, that would be past hour 14. I don't know, just keep it with P1. Maybe keep the gap closed. Sure. So that's a processing time of 5. And if you notice, I end at hour 20, so P1, or sorry, hour 19. So P1's done. Stop assigning stuff to him. Okay? So moving on to G, its prereqs are E and D, so it's got to be past both E and D. Okay, so it's got to be past hour, it looks like 17 or 13, I believe. So give it to P2 or P3. How about I'll just give it to P2 right here with a processing time of 4. And now G's out. Okay, G was past its prereqs, E and D. I gave it to P2. That means he must have been idle all the way up until that point. And then lastly, for H, H's only prereqs are E and A. So as long as it's past A and E, we're good. And again, that's at hour 13. Or is that hour? Oh, I'm sorry. I read that E as an F. This is an E. These are F's. So it's actually right here. All right, yeah, past this point, those are 3 E's to the left, and 1, 2, 3, 4, 5 F's to the right. Okay. So again, H has to be past both E and A, so it has to be right here as well with a processing time of 2. Okay. So there's the schedules: B, D, E, F for P1, C, then G, P3 with A and H. Again, the H's and the G's could have flip-flopped. Really, the F's, the G's, and the H, those could have all been flip-flopped, okay? As long as it doesn't exceed 19, we're good. If it's before 19, that means you might accidentally have some overlap, so watch out for that. So my final answer is 19 hours. So we got the project minimum time and the schedule. And just a last little question that goes along with project diagrams. Which pair of independent tasks? Getting out of bed and taking a shower. Okay, well, you got to get out of bed before you take a shower, so those aren't independent of each other. Building walls and putting up wallpaper. Well, you got to build the walls before you put up wallpaper, so that's not independent. Eating breakfast and brushing your teeth. Okay, well, depending on how you argue, though, you got to do one before the other. I say You eat breakfast and then go brush your teeth. And then lastly, D, vacuuming the carpet and scrubbing the sink. Well, it doesn't matter which one you do first there. Those are independent of each other. The answer is D. Okay, I appreciate you listening with me through this entire video. If you did, or if you just skipped around, that's fine. Good luck. If you have any questions, hopefully we can talk through them. Hopefully this video made sense. You guys are, again, as usual, awesome.